So what we wanted to do at this session, we call it the fireside chat, where we were going to go over some of Kelsey's tweets. And,
Be careful what you say on the internet.
and dive a little more into what he meant in each one of them. Some of them will be happy, some not that happy, we'll see. But end of the day, I'm not sure on what I'm saying. Arrived on an early flight from Tel Aviv this morning, so no liability here. So first one, can you see it here?
Yeah, I can see it.
So, well, we understand the learning part. What do you unlearn when it comes to serverless?
I think having full control, right? So if I'm in Kubernetes or a VM, I can do whatever I want, right? I know Linux pretty well. I know how C groups work. I can pick the runtime. I know how that runtime is going to interact with the kernel. I know what to expect. I know what my dependencies are. So I feel a level of comfort, and I feel that that's the way the world should work. If you go to the serverless platforms and you try to force that model into their compute platforms, you're going to have a rough time, right? They may not have the programming language you want. They may support the programming language you want, but not necessarily all the other dependencies that you have. So my first part of this was brute force and then trying to build something that makes it work. I think the first thing I did was IBM Cloud Functions, build my own custom runtime because it seemed to resonate with me more. And I spent so much time focusing on building a custom runtime that I never did the serverless things, which were dealing with the events, composing these services, and dealing with the other managed services around me. And I can see you have to unlearn that part. You have to just deal with the platform the way it is. You look at the platform, Lambda works the way it works, Cloud Function works the way it works, and you have to almost be willing to say, I have to deal with this thing as it is, versus trying to work around it, right? So the engineering me wants to work around it versus learning how it is, dealing with its limitations, and adopting it for what it is. So for me, that's kind of been my journey, is just letting go of some of the control.
So an example would be like keeping functions warm?
Yeah, like the cold start problem, right? Coming from a world where there's VMs and I can have as much compute as I want, what is the point of a cold start? Like, to me, there is no reason to have that not be a trade-off as an engineer that I get to make. Typically, engineering is about trade-offs, right? If there's a platform that says, for this price point, it will be slow. For this price point, it will be fast. Most fast platforms don't really have those knobs. It's just, this is how it works. So as an engineer, I'm like, there is a way I know that you can actually solve this problem, and it doesn't have to be slow, and I'm willing to pay. That is not necessarily an option for most fast execution backends, especially the ones that are fully managed. So for me, it's like, well, that's just going to be how that platform works. I'm going to have to deal with it for now, right? So that's something that I had to just kind of give up, that I may not be able to make that trade-off all the time.
Okay. By the way, I mean, if you want to interact in the discussion and take that question forward, feel free to
Yeah, if you have a
raise your
question,
hand.
ask.
Yeah, this is.
Go ahead.
So if we imagine serverless were 100 times more expensive, would they still make sense?
Oh yeah, so this is a good point. So if serverless was 100 times more expensive, would it still make sense? Honestly, I think the answer is no. I think there's a lot of, you gotta remember when Lambda was built. Lambda was built to me at a time where it's still a pain. I don't know when the bar got lowered to the point where we don't want a developer to know how to build a dependency. I understand the event model. Have a piece of code react to some event. You guys remember enterprise service buses? The same message. There's going to be an event for everything, and all you do is write a handler, and your life's going to be great. And then we couldn't figure out security across the board. We couldn't get every team to produce an event. So when I look at Lambda, I look at it as an extension of AWS itself. You use it to do things where it makes sense, because you still have EC2. You still have everything else. Same for Google Cloud. There are some people who look at it as this is the future of all compute. And then you try to wedge everything into it. So yes, if you look at the current pricing model and you run something 24/7, it is not cheaper. If pay per use and you're using it all the time, then what does pay per use actually even mean? Right? If you're going to rent a movie and you're going to watch it 10 times, buy the movie. Right? Like, it's like as simple as that. So I think some people don't understand. Pay for use isn't always the best option, right? Some enterprises, BigQuery's pay for use, they want more control, so they're willing to give us a big front payment, and they want to have some kind of guarantee that they can actually use it when they want. So as a cloud provider, pay for use also says, if I don't have the capacity, you can't use it. For some people, that means out of business. So I think we have to think about that as a trade-off again, and I think that's where we're missing in FAST is the trade-off.
A question that came up at one point when we were working on Knative that a user just asked was, hey, I'm trying to figure out how to run MongoDB on a serverless platform. And I think that's one of those examples of, this is one of the things that doesn't fit in serverless.
So in my talk, I talk about over-promising. When you say serverless to mean everything, then people expect you to solve everything. People should have said, hey, we're going to bring back event-driven programming with these function signatures that look like webhooks. You could say that. Then people say, well, I don't have events. So of course I'm not going to port my whole app to run as a function because I don't have events. If you don't have events, what are you doing? There are much better ways to run an HTTP server, and it's debatable. Since Docker, I do not believe it's that hard. Build packs. My developers don't know how to build an app. Wow. Like, it's okay not to know what you're doing, but at some point you should know how to build your app. How many people don't know how to build their app? That's why I don't let you code anymore. You don't get a keyboard. So I think if you ask most developers, they may not say building an app is the hard part. You could say maintaining your dependencies is hard. But I think this early pass and fast over-optimize on this, we will build your app for you. I think where we are in 2018, it's run this thing I give you. It's mine, just run it. And give me the different knobs to twist from a billing model. I think that is actually the thing. As a cloud provider, I know it is much easier if you give me a subset and I can make some guarantees because I can't run anything actually. It's actually dangerous to run anything that you give me. So half of this is the cloud provider doing what's best for themselves, imposing some of these limitations so we can actually meet global demand. Because if every customer in the world were to pick any cloud provider all at the same time and try to actually run all compute, it wouldn't work. There's no cloud provider right now. Can you go and say, give me 200 million cores? Not going to happen. Right, so unlearning that there's limitations to these platforms, and they come with benefits if you embrace the constraints.
Question. So, there's the question about if it costs as much as running on any other traditional type of infrastructure. Now, what about aspects of scale? Like being able to scale, scale up and scale down pretty rapidly on demand to whatever your demand is, right? So, are there benefits there? Because your answer was, take away the cost, cost benefit, and it doesn't really.
So let's talk about this. So what am I getting for this premium? Right? If you're using Heroku, you say, Heroku, here's some code. Heroku push, they did with scaling for you, right? And that gets you so far, right? If you think about it, most people are barely getting the Heroku experience, right? This is 8 years ago. You could get Heroku to scale your app for you. Then there's a problem in terms of you can't just think about the app scaling. What about your database connections? This is the first thing I see that people get surprised about. Wow, didn't know RDS had a cap on how many concurrent connections you can have. So we told developers, you don't need to think about scaling until your database does. And your database is like, no more connection. You're like, oh, what's that? So now you're thinking about scaling again. I can't just scale my app without any dimensions of upper bound, right? Because the other resources that it talks to will actually have side effects. You can't get rid of scaling. You can ask someone else to do the scaling for me. That's a different ask, in my opinion. So I think having people become naive about scaling and the trade-offs on scaling is not a good look. We don't need to continue down that path. If I tell you, I would like to use scale this app based on these dimensions, and I'm going to code my app to be as fast as it can, I don't think you just write crap code because the provider will scale it for you. I'm watching people have 4 gig functions. I thought this was a function. You need 4 gigs? What are you doing with the function? So I think we're slowly reverting back to old ways. I've seen monolithic functions. Anyone ever seen those? Big ass app with 700 entry points. I'm serverless. It's like, no, you're running a function in a thing. So I think some of these benefits.
I call it brainless.
Brainless? Damn, that's harsh. I didn't say that. So the platform does give you some base stuff, but it doesn't absolve you from the actual hard problems. We saw some of the patterns up here earlier. The fan-out pattern, imagine if a coworker came to you and said, look, I got this app that works. It comes up, it talks to Kafka, and I can process it with this one app. Like, there's some Go apps that can do 100,000 QPS with one binary. One binary, 100 QPS. And you say, no, dude, that's old. We're going to take that, we're going to turn it into a function, and we're going to do a fan-out pattern with multiple levels of queues, and I can tell you no guarantee about what happens to some of the messages. They're going to be like, why would I actually do that? Right? So there's trade-offs here. It's not about you're going to get automatic scale for free. You're going to move the scaling problem in different areas, and you can see it's not for free.
Right, but I mean, that all makes sense. But isn't that sort of a limitation to serverless? There's serverless, the concept, right? When we talk about it, it's a way of building applications. If you talk about the dynamic scaling, right? So let's say you could apply the same thing to those other resources, like the databases, to also scale them in that same sort of architecture.
I think it's better to say managed services. It's just easier. Like, is DNS serverless? Yes, it meets all the definitions. I go to some cloud provider, create a domain, they host this DNS server for me, the whole world can query that server, and they scale it to handle all the DNS queries that the whole world will make. That seems like it's starting to hit the definition. What about email? Does Gmail count as serverless? There's an email server somewhere. Handles all the protocols. Is that serverless? Right, so it's not just that a function equals serverless. Because if you had Lambda and you were running Oracle on a VM, is that serverless? No, you're running Oracle. And you're having a function talk to Oracle. So I think we're just calling this serverless idea of managed services, to me, is the only thing that resonates. A fully managed service. It can be compute, it can be data, it can be some other auxiliary service like resizing the image. To me, that's the serverless architecture. It helps you think about composing these things to build some app. But I don't know if one particular facet equals serverless.
That makes sense, yeah.
Okay, next one. Event-driven. So this sends me back to the 90s with CEPs, complex event processing. Could those platforms be built with serverless today?
So to me, I worked in finance, and these events were serious. You can't lose them. And if you lose them, someone would ask you questions like, where did it go? And then if you said, I don't know, then people would lose a lot of trust in that messaging system. It was pretty terrible, and we spent a lot of engineering effort as an industry to get reliable messaging. Persisted this, you would actually send it to 2 brokers and make sure that we got it in both places. Low latency links, some people have even custom network stacks to make these messages. This is serious business. Then I saw a presentation today, I was like, yeah, some messages you may or may not get. You may not know if you get them or not. You can see a graph that tells you how many you may or may not have gotten. That is not the same level of quality, in my opinion, of the robust, event-driven architectures where people die, right? Where you really need to respond or you die. We're not at that level, right? Now, do we need that is a different question. Do we need that for this to be useful, like a GitHub webhook?
I say yes.
Well, it depends. If you're building from GitHub and 99% of the time when you check in code, it fires your webhook, you're probably fine. If you have an IoT device that's watering your plants, it's going to send a message every 10 seconds, and you miss 20% of them, you're probably fine. You probably wouldn't even know you lost 20% of them. It's just for certain architectures where it's absolutely critical that I think that's unacceptable. So I think what we have today is obviously acceptable because people are using it today. But I don't think it's at the quality standards. There's probably people here that have really used really robust event-driven architectures that look at the current serverless offerings and say unacceptable. We can laugh them off as dinosaurs or they're old school or it's legacy. But the thing is, these are classic things that work at very extreme scale that you can only dream of. Like some people won't mention names, they call the cloud provider to warm up. Remember the load balancer thing? You call Amazon and say, hey, warm up my load balancer. The hell is that? So we know that there's scaling issues, so we're not quite there yet. It's still early, but I think if people understood that the event-driven nature will help them design their applications, instead of porting a monolith and breaking it into individual functions, you'll start to probably think a little bit more about the relationships between those functions, how they'll be triggered, what should they do when they trigger something, and then security isn't just who invokes the function, what the hell is the function emitting? Hey, here's my credit card data, first function. It just puts it in a random ass queue, and seven other functions get to see this credit card data when they had no business ever seeing that data. If you don't think about what the event and what the event holds, you're gonna start making these mistakes. This isn't a webhook replacement, right? So I think we need to think about these event-driven architectures. It's a different permission scheme that goes beyond the process boundary. You have to think about this data model that I think most people that have never done with the event-driven architecture are just now learning for the first time from scratch.
I think this is a very, very important conversation about what we really do get from serverless, right? Now, I've been in the enterprise as well, and we've talked, even today, we've talked a lot about on-prem deployments of serverless. In those environments, capacity is normally a constant. You have a certain amount of physical hardware or however they're provisioned, but it's constant. Now, if you're running serverless in that environment, you're serverless, but you're still running constant, you're not spinning up any new physical hardware or shutting them down. So you're running at steady capacity, but then, so in those cases, you find that serverless ends up sort of helping you allocate resources dynamically, more efficiently, because when you have several different applications and services running in that sort of environment, when one is trying to scale and you have a serverless deployment, what you see is that more of your capacity gets reallocated to those services that are trying to scale up, right? While others are scaling down probably at that time. But in the traditional setup, non-serverless setup, you have entire machines that are spun up and running specific applications, and when the demand or capacity need for that application is lower, the rest of that capacity is wasted, right?
Let's address this really quickly. So there's this thing about what's serverless. On-premise, if you were to adopt a serverless mentality, it would help you get better resource utilization, because there's this dynamic nature of spin this up, and if nothing's happening, nothing gets used. If you think about what workloads your enterprise actually has, that's actually a constant. Just because you spin it up and spin it down, spin it up and spin it down, who cares? Some people say that's the latency of doing that is not worth it. I have a customer trying to buy something. I don't care if a server is at 5% utilization. I'm making $100 per server. Waste it all. I've seen engineers do this. Oh, I'm going to auto scale because I want to save the company $20. Okay? I was like, I pay you $20 I paid you $20 to tell me that. So you say, there's certain parts of this scale thing. I think, if anything, there's this contract of an event. I like the idea that this event can invoke a specific set of functionality. I like the fact that I can give that piece of functionality a very limited scope in a security context to do only the thing it needs to do, separation of concerns. VMs were too broad. Everything on that VM inherits everything. The container in some ways can be a bit too broad for the monolith, depending on what's in it. But this event nature, where I can assign permissions based on the event, to me, that's the value. If you want to install a serverless framework on-premise, great. VMware said the exact same words you said. If you install VMware, you can now get higher utilization. You can actually create these VMs on demand. Some VM technology is actually really, really fast. Some things can spin up VMs in seconds. Maybe not milliseconds, but in seconds, you can get a brand new VM, and a few seconds later, you can log into it. So it's not the fact that serverless invented a way of dynamically using compute. We have other ways of doing this, right? So if you really want a function interface based on events, knock yourself out. But utilization, I don't think that's a solid story on its own. Not at all. Most enterprises are lucky to get to 5%, 10% utilization constantly across their fleets. You're better off probably doing batch processing before thinking a function is going to really get you to where you want to be in terms of high utilization.
Let's see what's next. This debate, containers versus functions.
There was a lady on the panel before, and she was talking about there is a need for you to be able to, as a user, specify what you want to run. The problem is the word containers is tainted. It's tainted with install Docker, then Kubernetes, then Istio, then this, then that, and then you can compute. So people hear containers and say, oh my God, there's no way I can be involved. Serverless uses containers. Yeah, but I'm not involved, so you feel comfortable. To me, there's the part there that I'm talking about here is that debating containers versus serverless is like debating electricity and light switches. You need the electricity. And the light switch is one interface into leveraging that. To me, the container image, how many people have been like, there wasn't a lot of sysadmins here, but I've been a sysadmin, and here's how it works sometimes. This developer writes something in Python, okay? They write this few K of files, and they say, hey, here's my Python app. And you try your best, and you say, okay, I guess it's Python 264, because that's what Red Hat has. So you do yum install Python, and you get 264. And you deploy it, and it works today. We update Red Hat. Now we're at Red Hat, I don't know, 6 or 7. Now it's Python 2.7. Shit should work. The app doesn't start. And then we get in this room, and we talk about it, and they say, hey, we should do this DevOps thing. You should know what I'm doing. I know what you're doing. And, oh, we agree now that the right version of Python should now be 3.2, and you update your code. And we do this, and we health check, and we monitor, and we ping, and we spend all this compute capacity to make sure that we have these things in sync. As a developer, who cares? Here's my entire app, Python, libc, every dependency. Don't look at it. Heroku went through this. I don't understand why we didn't learn anything. Heroku was like build packs for everybody. Then people said, your build pack is too old. You have an old version of Ubuntu in there. I need libc version 7.5. So now they have 5 versions of build packs. I want to run Haskell. God damn it, what's Haskell? You can't keep up with every language in the world. You cannot do it. So they said, you know what, give us a container, we'll run it for you. What's the problem? It's still the same computing model. So to me, even in serverless, people are like, oh, it has to be this function. Like, stop kidding yourself. There is a web server running your function. Stop pretending. And you're crossing your fingers that hopefully the provider doesn't update the runtime. Has anybody been using serverless long enough for the provider to update the runtime and your stuff doesn't work anymore? Yeah, you know. You're like, what the hell is this? I thought I wasn't supposed to worry. Not only am I worried, my customer's worried. Hey, your site's down. Really? Why is it down? I have no idea. So to me, the stronger contract, just like the shipping industry, if you really, really, really want to get streamlined and efficient, just like shipping containers, you put it in the container, we seal the whole damn thing, and we can build a whole logistics system on anything in those containers. That's why I think there's a bit of value in having it as an option. I'm not saying get away from build packs and no function signatures, but give me the option to give you my complete contract that can be reproduced 3 years later. I can't believe people haven't been in a situation where you need to reproduce a build. Hey, we have some discrepancies in reporting. The customer's unhappy. I actually need the old binary as it was 3 years ago, bit for bit, so I can run this data back through it to see what happens.
But isn't that kind of one of the great features of a serverless function when you're speaking of contracts, right? So you're event in, event out in some degree. And the idea of statelessness is that you don't make too many changes within that. But if you're processing some bit of code, you have to process an event, and you need to spit that event out, you can create that contract. And so whether you change your function from Go to eventually PHP or you're using Node or whatever you're using, as long as you meet that contract and you're communicating effectively, those individual building blocks become reusable for as long as you need to, and with the ability to upgrade.
So that is a great ideology of a pure functional world with no side effects. I actually have libraries that generate random IDs. Had a bug in one of them. The UUID on this kernel or the interface for generating random bytes was bad, had a bug. So at that time, the UID wasn't as random as I thought. It's not just in and then my code. The kernel has some say in this, right? So now I'm getting bugs from the random number generator. Maybe it's the libc is doing the wrong thing. Maybe the resolver is looking up DNS the wrong way. I changed some of those things, and now I'm getting a different result. I'm getting a different type of random thing. I'm getting a different DNS lookup path. This is different. These side effects are real. Now, if you're only processing data and you talk to nothing else in the world, this is the Haskell problem, right? The minute you want to do something else, like, ooh, that's an unpure function. Have you heard of monads? And you're like, I quit. I'm going back to Ruby. Right? So I think when you start to really interact with the rest of the world in the serverless architecture, managed services are a big part of the story. Your libraries have a lot of impact on what happens to what you're doing, right? So you can, like bad JSON parsers, bad YAML parsers, they have invalid YAML that still work. You go to a new language that is a little bit stricter. I saw this in Go quite a bit. Their parser was much stricter. It didn't allow certain things to happen in their YAML parser. So the same YAML that worked in Ruby did not work in Go. It's not as simple as having a contract on the front end and the back end. Your libraries actually can decide what works and what doesn't work. And I think that's why I need to be able to reproduce these builds so I can have some confidence that this part of the state machine is actually, I can pair it back up. So this event version, this output, but this piece of code. This is a big problem in data science right now. People can't reproduce the results. Hey, our findings are this. All right, let me run it. Well, I don't have the code.
I mean, isn't one of the challenges that those of us that have been in kind of the enterprise space, that we outsource all that conformance, that architectural client server, web client server, whatever, conformance to the vendors, regardless of what they were, open source-ish or Oracle types idea. And now in the as a service world, in essence, they're downsourcing the state management back to the customer. But we don't have a contract. I mean, we're not even set up to handle that, right? We're barely getting off of the rationals and the VCSs to just try to get to CI something. And you know, the idea that we can manage state and performance simultaneously just doesn't make any sense.
Yeah, so I think we're still talking, and sometimes these conversations feel like an all or nothing proposition. The reason why all cloud providers offer all of these compute options is because we know there are different things you need to do. For example, I think someone earlier, how do I run MongoDB inside of a serverless function? Like, why do you want to do that? But why? I don't know. Seems cool, right? Isn't database just a function? It's like, yeah, everything's a function. Function main, that's also a function, right? Just use it on a VM and you'll be fine. So I think we have to understand that these are just trade-offs for different paradigms. And if you don't have any events, using fast with no events, I don't get it. So in your case, it's like pick the best paradigm that's best for you.
But the challenge is that the providers have an opacity in the conformance of the underlying architecture that you have to, I mean, you can't even read leaves, and there's no way to tell. So if you have a BLA or SLA with your internal or external customer, you sign that, but you're promising a future that you don't have any control over.
So
that makes the buyer much more conservative.
Yes, so if you sign a contract with a real customer and you tell them that your service is going to be up a certain amount of time, and you were talking about let's not worry about scale, I'm going to tell you the first day this becomes moot. If Lambda is down, who cares who fault it is? You're going to revisit the conversation because no one else cares. They're going to say, listen, buddy, we just paid $1 million back to this customer. I need you to give me more reassurance, even if it's just you working throughout the night watching the VM. I will pay someone to watch my VM so I don't pay out the $1 million. There's a bigger cost analysis outside of how much does it cost to execute a piece of code.
The problem is then the response tends to be, let's fold back to a JVM world. Let's go back to the J2 node, let's go back to the legacy monolith-ish kind of architecture because you had more perceived controls because the performance was responsibility of the vendor.
I mean, you just got to be smart. So we'll move on in a second. I think you got to be smart. Like if you try to hang a painting with a jackhammer and you blow up your whole wall, and someone says, you could have just used the hammer for this one. I know the jackhammer is super powerful, has all these things, but you just got to be smart and say, why did you pick this thing in the first place? Most people can't even get past that. If I just ask you, look, you have Lambda, you have App Engine, you have Kubernetes, you have raw VMs, why are you picking the one you're picking? Just write it down on a piece of paper. Why are you picking that one?
Well, so I think we've missed one thing in the conversation, which is that me as a customer, we've talked about the architecture in general, right? So serverless and all that, ultimately it's still running on a server somewhere with security and a whole other parameters. But for me as a customer of the serverless provider, right, the contract is different for me, right? So the cost contract is different. It's very different to me. Like if I were running a VM where I'm paying the cost, the whole time. And that's just one example. So it may look the same, it may walk the same, which is a lot of the argument you're making if you really take a look at it. But for me, as a customer of that cloud provider, it's now, my experience, my contract is now very different.
You have choices. So all I'm getting into is you have choices up and down this continuum. You can choose pay-per-use. If you do the math and your usage is, let's say, you end up with $1 million bill, and someone comes to you and says, look, if you rent it on a VM, I can make that $10,000. That's what engineers should do. We should look at that and say, that's the trade-off. Is it just cheaper to run it? In your eyes, it could be inferior platform. There's reasons why we make these trade-offs. That's only the ask that's present being here. Pay-per-use, take on some responsibilities, and it may get cheaper. You have to do the back of the envelope. If it's still cheaper, of course use the serverless thing.
So how many years into the future will I as a developer not have to actually choose? I just have compute that I want to run, and whether it's run in some container server, bare metal, that's not the interface that I interact with.
That's a deep question. When in the future will I not have to choose? The closest thing that I've seen today that is promising is what Docker did. Forget everything else. If you look at Heroku, App Engine, Cloud Foundry, Kubernetes, all of these platforms support the container image. It's pretty close to your expectation. You put things in there, you run it, you get an endpoint, you can call it. As a provider, I can put any pricing model I want around that, right? I can charge per use. I can put it on the VM. I can put it with 10 terabytes. I can do whatever I want. I can even run it on the data array myself. That's the closest thing I've seen since the virtual machine that we had something that's above bare metal. That's the first time. Yet, I don't think people are sold on the platform layer that that should be the compute input. So maybe it's another 20 years.
With that, we're done. Right, Daniela? 20 years.